Okay, today we're going to look at combinations, and you're going to see that they're very similar to permutations that we did earlier, except the main difference is combinations, the order doesn't matter. So for a permutation, the order matters, so that means we have like first, second, third, or we're arranging letters of a word, so the order matters, or we have, we're going to line up people or cars or things like that. So anything that's in a line or where order matters, we use a permutation. Where questions that we don't care about the order, so that'd be things like I'm going to pick a team, I'm going to pick a team out of a group of people, or I'm going to get cards dealt to me. So when you get cards, you can mix up the order, that doesn't matter. Lottery numbers, those kind of things. Pizzas, right? Doesn't matter what order they put the toppings on your pizza. So those kind of questions you get, we're going to use combinations. So first, let's kind of compare how they are similar and different to a permutation. So let's suppose our first example is, let's suppose I have, I want you to line up 3 people out of 10. So the question is, how many ways could I arrange 3 people out of 10? We would go 10p3. And what that means, let's just quickly review the p notation. That means we have 10 factorial, we have 10 different ways of arranging people, but we're only using 3, so that means we've got to get rid of the 7 factorial. So when we did this with multiplication, we said we had, because we only have 3 spots, we have 10 people for the first choice, then 9 people for the second choice, and then 8 people for the last choice. So now, if I said we're going to have 10 people, but instead of lining them up, I just want to make a 3-person team. So in terms of a team, we don't care what order they're picked in, they're all going to be on one group anyway. So because it's a team, we have to use a combination instead. So on your calculator, when you go to the math over to probability, you can see the permutations are number 2, they have NPR, and then for the C's we use NCR, which is the one right below it, number 3, and that's really the only difference. So in terms of a combination, just to kind of show you how they're different, is we still have 10 people we're picking from. We're still only using 3, so that means we don't need the 7. But now, out of those 3 people, we don't care what order they're in. So it's just like, remember when we do the questions where we have a word, like let's suppose I give you a word like Kalmar. When we did that, we had 6 people, but then we had to divide by 2 factorial because the A's repeated, right? We didn't care what order the A's went in, they were the same thing. So it's the same sort of logic for a combination. You have to divide by the repetition. So we have 3 different people in line, we don't care what order they go in, so we actually have to divide by the 3 factorial. So in this case, if you actually were to do you couldn't do the multiplication, it'd be too tough to do. You'd have to go 10 times 9 times 8, but then you have to divide by the way you could arrange those 3 people, which would be 3 factorial or 6, whichever you want to write. So that's sort of the main difference, is why are the permutations and combinations different. Permutations, the order matters, so we don't have to worry about dividing by the way you could arrange the items. Combinations, the order doesn't matter, so then you do have to divide. So for these kind of questions where you get grouping, you're better off to just use the p notation instead of trying to do it with factorials or with the multiplication. On your formula sheet, they give you both formulas, and they're kind of confusing, but you can see on the last question that's exactly what we did. We do, for NPR, you do the total factorial, and then you got to subtract the parts you aren't using. So for 10p3, we went 10 factorial over 10 minus 3, which was 7. And then for NCR, it is the n over n minus r, so the same thing. But then we also got to divide by the r by itself, because those order doesn't matter, so we have to divide those arrangements. So those 2 formulas are on your formula sheet. So it just depends on what it is. So for example, let's do a card question. Let's suppose I was going to deal you a 5-card poker hand out of a deck of cards. If, for whatever reason, it usually doesn't, but let's suppose order mattered, you would have 52 cards in a deck, and I'm going to give you 5, so you'd have 52p5. If order didn't matter, we would use the same thing, but you'd use the C. So most card cases, it doesn't matter which way you get the cards, you can rearrange them however you want, so we'd use the C for most cases. Okay, so using these formulas, the difference would be 52 factorial over 52 minus 5 is 47. And then for the C notation, we use 52 over 47 again, but then we also have to divide by all the different ways we can arrange those 5 cards. So that's sort of the key differences between the two. Let's do some examples of why you'd want to use the C notation. So let's go through. The first one I got is, let's suppose we have 9 people on a team. So let's suppose we got 9, we're going to do a basketball team or baseball team or something like that. Let's do baseball. So let's suppose we have 9 players and we have 5 males and 4 females. So that's going to be our softball team. So let's do a few questions based on that. So the first question is, how many ways can I choose, let's suppose, how many ways could I choose any 9 players on the team? Okay, so does order matter for the team? So I want all 9 people out of the 9. So order doesn't matter, right, because it's a team. We don't care what order they're lined up in. So in this case, if you were to do 9 out of 9, where order doesn't matter, you want to go 9C9. And that's basically going to be 9 factorial divided by 9 factorial, which is just going to give you 1. So when you do 9P9, where order matters, it's 9 factorial. 9C9, where order doesn't matter, you're only going to get 1. So that's kind of the big difference between these. So because we're just picking 9 out of 9, where order doesn't matter, we only have one arrangement, all 9 people. Okay? How would it be if I said, let's suppose we're not going to do baseball, I just want to do curling or something like that. So how would I take 4 out of the 9 people? So if I want 4 of the 9 people, then we would have 9C4, order doesn't matter. So that one on your calculator is going to be a little bit different. It's going to be, let me just find my calculator here. So on your calculator, go 9C4, and you get an answer of 126. Okay, so that would be the answer for that one. Let's do a couple more. So what would it be if I said I want 2 males and 2 females? So we want a team of 4, but we have to have 2 of each. So in this case, you just got to be careful, because then you'd have, out of the 9 people, we have 5 and 4, but we only want 2 of each. So then you're going to write 5C2, right? We want to pick 2 of the 5 males. And then we have and. Remember, and means times. So 5C2 times 4C2, and then just do each of those on your calculator. So you'd get 10 for 5C2, 6 for 4C2, so we get an answer of 60. Okay, let's suppose we still want 4 people again, but now this time I want all 4 females. So that one's an easier one because there are only 4 females. We're basically picking 4C4, which is just like our first one. We have 1. There's only 1 group of 4 females because we only have 4 to pick from. And we'll stop there. We'll do more of this in class and kind of explain the differences and do a couple more examples, but that gives you the basic idea. So P notation, permutation, order matters. C notation, order doesn't matter for combination, so that's why you want to use the different calculator button. P's typically will always be a way bigger answer than C's because we don't have to worry about dividing all those numbers when we don't worry about the order. So we'll stop there.